I am on the Tor Research Safety Board. I have done some work in the past in doing investigations and experimentation on Tor in a more safe and secure manner. So today's talk, I'm just going to give you a kind of an overview of the land, give you some user studies or case studies of previous research that has been done in Tor, trying to look at risky things in a hopefully safe manner. So let's get started. All right, so very, very generally, I know we're at NDSS and everybody knows how the internet works, but I thought I'd just give a kind of a point towards a specific thing so that we can use this as a running thing throughout the talk. So the internet is a pretty opaque place. Basically, you have a bunch of machines connected to each other. They never get to see each other. It could possibly be that, you're talking into the void. And the only way you know you're connected or anything is happening is when you hear things coming from the other side, right? You can think of your life as living, that machine on the internet as living basically inside a cardboard box, right? Messages come in and that's your only way of knowing anything is actually happening, right? So machines, get added to the network. So you have their presence announcements like our broadcast, things like that, right? And that's why we have all of these protocols to keep things working, right? So, are we talking to the right endpoint? And that's like authentication. Are we sending the right messages? That's like integrity. So to keep things going, to keep things functioning correctly, right? And in order to know what is going on, right, we need to do a kind of, we can't just expect things to become apparent to us to let us know how things are working. So we need to monitor the network, right? We need to collect basically a lot of logs, lots and lots of logs, right? The routers on the internet are collecting logs, servers connected to the internet are collecting logs. There's logs everywhere, right? And we use these as a way of knowing what is going on, right? So this measurement and observation is basically how the network or the internet basically, we can know if it's working properly, it's in good health, right? And also it lets businesses know who provide these network services if they're meeting their service level agreements, basically, making sure that the servers are up, 99.999, however many nines you like, percent of the time. Things are really fast when they said that they would be fast. So basically, we want to know if everything is going okay, right? And of course, our research into networking also depends on measurement observation, right? We want to know if a new protocol that we wrote is actually faster and more secure than it used to be. We want to make these advances so we can have a faster internet. We can have applications that are more featureful, right? So measurement observation goes hand in hand in both keeping the network running as well as ensuring that we can, do research on it and be able to improve it over time. So it's the same story for Tor. Tor is also a network. Tor is an overlay network, right? So we have measurement and monitoring in Tor. So we want to know how Tor is functioning, right? So we want to look at the real network traffic of Tor. This means necessarily looking at traffic of real people, going over the actual machines that are in the network, right? So this is something I want you to keep in mind, that when I'm talking about monitoring and measuring, we're talking about actually looking at real things, real people's traffic. Right? Now, why would we want to do this? There's many reasons in Tor why we want to do this. So there's load balancing, to know how we can use the resources that are available to Tor in the best possible way. We want to identify any problems or bottlenecks, like maybe there's something wrong with the path selection algorithm or the routing algorithms. And, to ensure that we're getting the most out of the Tor, the resources that we've been given, right? We want to know if we can evaluate the modifications and if they have the desired effects, because often we come up with some improvements either from the research side or the Tor developers themselves. And we want to know if, things did actually improve. So if you never measured, you wouldn't know if anything has become better, right? You also need some sort of measurement and monitoring to know how well things have improved, to tell or inform policymakers and to justify the investments from funders and volunteers. They want to know if, money is being well spent. And one way of knowing that is to see how well Tor is functioning and if it has been improving over time. Okay. to support all of this, Tor has been, doing these measurements and monitoring. Tor has, you can actually access all of this information from the Tor metrics website. This is an in-house Tor's own metrics measurement platform. They have various ways, tools to evaluate the performance of Tor, how things are working, and these are all reported on the Tor metrics portal. You and I can actually go there and just download data and analyze it if we like. So this is all available to everyone, okay? And so that's great. All of these things are really good, and we should be doing them. And in fact, that's what's needed in order to keep Tor functional, to make sure Tor improves. But then, the more we want to know, sometimes we come against things that are potentially more risky. And that's the thing with Tor. It's a little bit different. It's an anonymous communication network. It's meant for privacy, right? So whereas in other networks, we might be able to ask, like, where are people going? What destinations do they go to? What protocols are being used? Asking the same kinds of information about Tor, it feels or starts to feel a bit more risky, right? Like, how do people use Tor? What are the most popular websites people are going to over Tor? What are the most popular protocols? Also, where do users come from? I mean, these are also good questions. Of course, we'd like to know these things so we can improve Tor and make it work better. Like, for example, where do people come from? Where do users coming from? It can help us detect censorship events and also help us, figure out how to deploy Tor bridges if you know about them. So basically, all of this information is actually quite useful. It's not just idle curiosity. So this would actually be helpful for us. So getting back a little bit, Tor has a very good, I believe, as a researcher myself who's done work in Tor, I feel like Tor is very open to the research community. There's been many measurement studies done basically around performance. There's been many experiments done to validate attacks and defenses. So all of these have been, a lot of them have been done on the actual real live Tor network, right? So that's great. Tor is open to the research community to use it, the live network, for running experiments, right? For experimentation, if you can do it, in a safe manner, right? Now, of course, Tor started around, I would say, became really popular or started to becoming popular around 2005, 6, sometime like that. And at some point, we started to see those risky questions being asked. And so there was this paper, Shining Light in Dark Places, Understanding the Tor Network by McCoy and et al. At PETS 2008. Okay. So this was an experiment. This was a study basically done to find out, where do people go on Tor? Where do people visit? What kinds of protocols do people use on Tor? In what fashion do they, are these protocols evenly distributed? Are more protocols more popular? How, basically, try to dig into how users are using Tor. Okay? So on the surface, that sounds like that's a really cool, that's a really good thing. We should try to find these things out. But, and now this is stuff of legend. This is before my time. I started grad school right around 2011. And already by then, this was already legendary. And so basically what happened is at the conference at PETS, and you should kind of have in mind, the PETS crowd is very, very much into privacy, right? It's a privacy enhancing technologies symposium. So people are very, very, think it's a very important thing, as they should, as it is, right? And so there was a backlash that actually this experiment, these sets of experiments may be exposing actual people, real people. You've collected information about real people, right? So could not somehow, by doing these experiments, you have revealed either to yourself or to someone else who will take a look at your experimental results, something about where people might actually have visited, for example, right? So that kind of set a chilling tone in terms of wanting to do or being able to do more risky, trying to figure out where people are actually doing, specifically user behavior type questions on Tor, right? And so basically by the time I started grad school, this was already kind of a feeling that, it's not the case that you can just do whatever experiment you feel like, right? There are some things that you have to be extra careful about, And I feel like, it was kind of like, okay, we'd like to do it, but we don't know how we might do it in a safe way, right? Okay, so I've been giving you a very high-level view here, and I'm sure that a lot of people are very familiar with Tor, so I'm just going to do a Tor speed run, just because I want to point out certain things so that when I talk about actually collecting information on Tor, it becomes clear like what is the specific problems that I'm trying to point to. Okay, so basically, as we all know, Tor is a low latency network. It's an overlay network where packets are routed, source routing. The client decides which path to go over, right? It can only resist a local adversary, and this is extremely important. This part is actually very, very key to a lot of this stuff that I will talk about later. So the local adversary basically means an adversary who can only observe some parts of the network, can only compromise some machines on the network, meaning that it's limited in its view of what is happening globally on the network, right? So there's no adversary that you can say, either a collusion of adversaries or just a single adversary, that can observe the entire network. Because if you did have that kind of adversary, basically a global adversary, then Tor is not within Tor's threat model in any case, right? So this is something to keep in mind. The adversary is limited in what they can learn, where they can be, and what information they are able to gather. So, as the name suggests, Tor is protected by onion encryption. I won't go into the nitty-gritty. Actually, I will go a little bit into the details. And it has constant size packets, like fixed sized packets to prevent, pattern matching and things like that. So all basically done so that the adversary does not know which two endpoints are communicating with each other. Basically, this is what we call sender-recipient unlinkability. So the source and destination can't be linked together. And the other property, this is from the perspective of some third party. And the other thing is that if there is some recipient and the sender does not want to expose themselves so they don't name themselves, no recipient can tell who is actually sending them a message. So that's called sender anonymity. So both of these properties Tor is providing. Okay? So basically, keeping in the spirit of a speedrun, Tor is an overlay network. There's a bunch of relays run by volunteers on the network, and the user will create a path through the network, right? And from its like some node that it picks as its first hop in Tor, a client will pick one node, and that will always be their node, the guard node, right? There's reasons for why that is the case. It's for security reasons, right? And then pick two other nodes in the network and basically try to construct a circuit that goes from them towards the destination, right? So using onion encryption, it creates a path to the first hop. Then it makes an extension of that circuit, that path to the second hop, and then the same thing to the third hop. And then finally, it's encrypted with onion encryption. I'm not going to go into the details of this because it's not super relevant, but the main thing to understand is we're being extremely careful here. All this work just so we can ensure that the local adversary who can't observe the entire network will only have a limited view of what's going on. So if it happens to be that the adversary is sitting between the client and the first hop, they'd only see that path, right? They wouldn't know where's the destination because it's inside several layers of nested encryption. If the guard itself is malicious, it'll only know what the middle hop is and the client. They'll know the client's identity, but they won't know where they're going, right? The middle hop has no clue who the client is or who the destination is. And also, if there's an adversary kind of in that neighborhood, they will also see some guard sending traffic to some middle node and some middle node sending some traffic to an exit, right? They won't know what the endpoints are. And same thing with the exit. The exit will only know the destination. The destination, but it won't know the client. And if there is an adversary in that neighborhood, or if the website itself, like Twitter or Facebook or whatever, is compromised, they won't know who the client is, right? So all this work, so we can keep this sender-recipient unlinkability going, we can keep sender anonymity present. Okay? So, and that's basically why Tor is doing all of this hard work, like all that heavy lifting, all that encryption. Good. So something to understand is also that all these nodes, they're untrusted. We don't trust any of them to actually not be trying to de-anonymize us in some fashion. The only thing we want out of them, or the only thing we hope is true, is that they're not all colluding, right? In fact, we expect the majority of them not to be colluding, right? So basically, they don't share information with each other, okay? And the fact is that because of these untrusted nodes, we're basically saying it also means that then the adversary is local. They have a partial view of the network, as I just said, right? So given this is the setup, right? What is the kind of attack that we are kind of worried about? Now, of course, Tor does admit certain kinds of attacks, okay? It's not perfect, okay? It's not like a security guarantee that, if you have this many nodes that are honest, nothing bad can happen, no one can tell where you're going, right? It kind of scales with the number of bad guys or the malicious adversarial bandwidth there is in the network. The main thing is that we just want the adversary not to gain a disproportionate amount of attacking power. It should be in proportion to the amount of investment and proportional to the amount of bandwidth that they're giving to the network, right? So with that said, what we're really worried about is end-to-end compromise, right? Like you want to make sure that the adversary has a hard time correlating traffic between the guard node and the exit node. So like if they can observe traffic going into the network on some point, like the guard node or from a client specifically, and they observe some traffic going to a website, we'd like it to be as difficult as possible. Now, of course, it's not to say it's impossible, right? Because we know Tor is a low latency network, it will not do any kind of obfuscation of timing. So you could use some timing patterns to discover and maybe try to confirm which user is talking to which website, right? Now, of course, this all depends on the adversary's budget, how many exits they can run, how many guards they can run, so that they get a more complete picture. Because if they have an incomplete picture, they don't know the traffic they're observing at the exit is perhaps originating at some uninvolved or something that they are not actually targeting, a non-targeted user. And on the other side, they don't know the traffic they're observing at the guard side is actually exiting at a node that they control, right? So again, even though there is the possibility to attack, do an end-to-end compromise, the adversary is limited, right? So the whole thing is based around a limited adversary, okay? So what makes measurement on Tor different then? So the technical reason, as I've been setting everything up for us to be able to say this, is that perhaps attacks are easier, this end-to-end compromise especially, or made more feasible from the collected data. What if I can reveal missing information to the adversary? Like I run an experiment at the exit, I collect a bunch of data, and I say like a gift basket, like here's some data, right? I collected it during these times. I got my research paper out. It was great. It got accepted. And here's the data because I'm making it available, right? So the adversary could say, oh, I was monitoring some particular client at that time period. Let me see if I can do some correlation in the traffic you've given me as a gift. Because I wasn't able to deploy nodes everywhere. You invested your own resources, did deployments, and collected this data for me. So thanks a lot, right? So the worry here is that, am I somehow helping the adversary by providing them with information I've collected, right? The other side of it is perhaps my experiment degrades the network somehow, right? Like it slows things down, or it tries a particular routing protocol, for example, that is very greedy, for example. And some clients are getting a lot of bandwidth and some clients are not, right? So sometimes, another way of looking at this is sometimes it's difficult to tell an honest but curious experiment from an attack, right? It's hard to tell, right? So those are basically the technical reasons for why measurement is different and a little bit more challenging in Tor, right? There's the other aspect of it, and I think some of it touches on the backlash for that work I was talking about earlier, okay? It's around expectations. The social contract. Like you would say that, if you're a relay operator, we want to have, trustworthy relay operators. They shouldn't log anything. In fact, part of the instructions for running a relay is please do not log, right? So because the reason is Tor is for network privacy. So Tor is trying, at least the organization, the project, is trying to have people doing good practice, right? And part of good practice is not keeping logs, which kind of goes against the whole idea of, log everything so we know what's going on from the network measurement and observation point of view, right? So basically, in other words, honest relays are not supposed to watch what you are doing, right? Of course, this is just a very loose social kind of expectation. No one is saying that it prevents anyone from doing whatever they feel like, right? It's just that there is a certain social pressure and something like that can be applied, at least to the honest people, okay? So, and as I'm talking about all of this, I'm kind of addressing it to the researcher who basically is trying to do things as best as they can in an honest fashion, right? I'm not addressing this to the bad guys who are trying to, break Tor, break the security of Tor, or anything like that. All right, so I'll move on. So that all said, around 2013 or so, I was asking myself, I was working on censorship resistance, and I was like, how do I know if my censorship resistance tool is actually working, right? And, it was in conjunction with Tor, right? So I was like, how would I know if people actually benefited from me making the censorship resistance tool? I guess the one way to find out is see the popularity of different websites when my tool wasn't present, and then with the use of my tool, maybe the popularity of some websites will increase because people were able to use my tool, or so I thought, right? I mean, in a nutshell, the question just boils down to where are people going? That same question, right? And so that's an interesting question. You want to know every so often, like, where are people going on Tor, right? What's the popularity? Because another thing is that often when we do Tor research, like website fingerprinting or any of the other things, we often are like wondering, oh, I need to model a user. I need to model where they go. I know I'll use some top 1,000 or 1 million popular website list. These days it's like Tranco. In the past it was some other ones. And the idea is that if these are the popular websites, I guess people will also be going to the same websites with the same kind of popularity distribution on Tor. Of course, there's no reason to believe this. I mean, other than just kind of like wishful thinking, right? So that's another reason why you might want to say, here's the Tor top 1,000 websites, right? I mean, we don't have such a list right now, but it'd be great, right? It'd be a little bit more validated than just this assumption that whatever happens on the clear plain text internet, well, not plain text, I mean, the non-Tor internet happens on the Tor internet as well, right? So this is kind of interesting. This is what we want to do, but there are risks, right? So the risk is obviously there's an address sitting between the client and the first hop, the guard, basically local somewhere around the client. They know the client's identity, right? And they just collect and harvest statistics about their access to Tor, right? After we run the experiment, we provide the data because we want to be transparent. We want to provide data. It's always good, artifacts, right? And basically, maybe we're not careful, we provide some fine-grained statistics about the visits to websites over the course of a day, for example, right? So the adversary could use this information to correlate the clients who were active in that time and match it to traffic patterns to the website, especially like a website that's very infrequently visited, like somebody's, who's writing under a pseudonym, some dissenting blog post or something like that, that's anti-government or something, anti-authoritarian. And so this might get them in hot water, right? So obviously the risks are there, right? So, but still, it's an interesting question. So we did such a study, right? And the system we made was called Privex. But what we needed to do, as we thought about this, we're like, okay, we really want to know. We really, really want to know the answer to this question. But we can't just do a study. Otherwise, people will get mad, right? And yeah. So we need to reduce the risks, all right? So we want to make it so it's difficult to use the collected data to do attacks, these correlation attacks. We want to make it difficult to steal useful data from the experimental setup, like in case someone breaks into our machines while the experiment is running. And we want to make it difficult to steal data if someone were to, kidnap us, right? And make us reveal the plain data or the raw data, right? And of course, we're like, okay, we'll do all of this. We'll try to figure out a way of doing it such that these things are true. But at the end of the day, the benefits should outweigh the risks. And here in this case, we believed that they did, right? I want to say also, this was before the Tor Research Safety Board existed. And I'll go a little bit into like how this kind of plays into creating the Tor Research Safety Board. Okay, so I'll give you a quick overview of PrivX because I think it's interesting to also get a sense of what tools are available in case some of you are also thinking about running Tor experiments or have run Tor experiments in the past or are just wondering like if I can get some more tools in my tool chest, right? Okay, so this paper appears at CCS, so the system's called PrivX. Basically, that's me on the right there. It'll be right for you as well. And basically, I want to just observe all the traffic leaving out of exit nodes on the Tor network and just record which destination it's going to, okay? And basically get a website popularity index, okay? But I need to do it in the way I just said, where I ensure that back stuff can't happen. So in order to prevent the correlation, basically, if I take the data itself, the raw data, how can I protect against there being correlation attacks? So what I want to do is make it a bit less fine-grained, a bit more messy, right? So we do this by adding noise, specifically differential privacy, right? Differentially private noise. The reason is, of course, that differentially private noise has been shown to be like the gold standard in, adding noise where you know the utility loss based on how much noise you've added and you know what the security gain is as well. Or at least you can kind of bound the information leakage, right? Okay, great. So once we have the data, we can add noise to it. But what about if someone breaks into the machines while the experiment is running before we had a chance to add the noise, okay? So we use secret sharing, just simple additive secret sharing. There is a distributed decryption and encryption version as well of PrivX, but I'm just talking about this more simpler case because this is the one that's been used more often by other people as well. It's just additive secret sharing, right? And the idea is that you initialize all the servers that will be collecting information, all these exits that will be collecting the stats, and initialize all the entries for each website in a randomized fashion, right? So if someone does and do it in a way that you take all of these entries for these websites for you, right? And you secret share them such that you break up that particular measurement into in our case, it was 3 pieces, right? And you deposit each of these pieces with what we call share keepers. These are servers there to help out with the protocol, right? To keep things safe. And basically, then you would just do the monitoring and incrementing of this randomized blinded value. And if an adversary does break in to watch, they wouldn't be able to tell exactly what the value was because it's secret shared, right? And finally, how to ensure no compulsion. Because it was secret shared across multiple servers, you'd have to, as an adversary, break into all 3 servers or compel the researchers in all 3 sites to give up information about those servers, about the secret keys used, right? But the thing was that once we initialized everything, we deleted all those secrets, right? So even if you were to, kidnap us, after the experiment started, there was no way for us to undoing, right? So this whole setup basically ends up with all the statistics collected at individual exits. We only learn about the aggregate value, right? We only learn one list across all the exits. So it wasn't the case that each exit gave us its own list. These were all aggregated. So we were also aggregating all the stats across all the exits that we ran. So we ran this over, basically we did a smaller study because it's the first time we were doing something like this on 3 nodes, 3 exits, right? And we used 3 share keepers. And yeah, so we did basically this study on that kind of thing. Subsequent to this work, there were other works. There was one work by, I believe, Rob, who's in the room. They improved PrivX with PrivCount. I think that's something that people are using more now as the kind of thing to use. There were other works at NDSS, at CCS, basically around enhancing and improving the kind of capabilities and the kinds of things we could count. It's because PrivX was about just counting, basically summing things. And so now we have the ability to tell like the size of a set and things like that, right? So basically, we see that there has been uptake in this, people wanting to use this thing because there were questions that people wanted to ask, but they were too risky. And this kind of work helps to de-risk that kind of study, those kinds of studies. Just a note here, as you see the dates in these papers, the Tor Research Safety Board started around 2016, and this paper was presented in 2014. So we're seeing that, there has been, basically what we're getting is acceptance by the community. So basically, what did we learn by doing this? We learned that risky data collection is possible, right? But the experimental setup becomes way more challenging, right? So we made some new tools, made them available to the community. We learned how to conduct this sort of study, process. It wasn't just the maths and the cool programming and stuff like that. There's also, finding out how can we, get feedback from the community? How can we learn, to do things to this and better? And also it introduced a community, at least the Tor community, to the idea that we can do this safely, right? To try to reduce the amount of risk that people felt about doing this. So that was like asking risky questions, right? Like straight up, where is someone going, trying to probe these kinds of questions, which goes against the privacy of Tor, right? But what about performance, right? Just statistics about how fast things are, right? Surely some data is inherently not risky, right? Like performance seems low risk, right? But that's not always true, right? So let's take a question. What is the true capacity of the Tor network, for example, right? And so this is a paper that I'm going to talk about, is on the accuracy of Tor bandwidth estimation. It's by Rob and Aaron. It was presented in 2001. And basically the question they ask is, we suspect that the Tor network is underutilized. The capacities of these relays, especially big ones, are not being accurately measured, right? So I know what they said, why don't we overload and stress test these nodes to find out what is their real bandwidth? Because the way it works right now is only opportunistic. It depends on how people are using it. So it's kind of limited by how often things get used, okay? So this estimating the Tor relay capacity experiment, right, is basically, it's important to know why. It'll help us figure out if the load balancing algorithm, the load balancing process, where its weak points are and how it can be improved, right? So it's not being done just for curiosity's sake. It's being done to improve the Tor network in some fashion, right? So the thing they do in the study, right, is first they try to look at the data that's already available through the Tor metrics website, right? So they analyzed published data on throughputs about relays, they analyzed it, and they actually did find that, there's a trend. There's a trend that it looks like things are underestimated because of the variance that we're seeing in the things. So let's do this real world speed test, right? I'll just point out here that while they were doing the speed test, it actually shows up in the Tor metrics website. You can see this big bump, and that's basically Rob's experiment over here. So mitigating the risks. One thing that they do in this work is to ensure that their experimental machines, and basically experiment, because they're going to add machines into the Tor network, relays into the Tor network to do this experimentation, to do these speed tests. They try to ensure that no non-research users or basically unrelated traffic will not come to them, or at least try to limit it as much as possible. It's impossible to completely make it, probability zero, but they try to do it in such a way that no real users will actually come through any of their machines, right? Now, I said that they're going to stress test the relays on the Tor network. So they do this by limiting the overhead on any given relay, right? So what they do is a 1 gigabit per second speed test over each relay. So they only do one relay at a time. There's around 8,000 relays in the network. So they hit one relay at a time. They do this speed test for like 20-second duration to keep the impact on this particular relay low, right? And so the Tor network in its entirety is not like significantly impacted, but they were able to, do a good test of an individual machine, basically, right? So by the time they were doing this study, the Tor Research Safety Board existed. So they engaged with the Tor Research Safety Board. They submitted an application. After the review, they got the no objections result. Basically, they showed us that they have thought about the problems, they've mitigated the issues, and the benefits are outweighing the risks of this research, right? What they also did, and this is, again, part of the process. This is not just trying to figure out how to do things in a technical point of view. They also engaged with the Tor relays community. This is the community of operators or people who run Tor relays, right? There's a mailing list for them, right? So they posted their experimental design and why they're doing it as a public post on a Tor relays mailing list. They provided opt-out instructions to allow relay operators who do not wish to be stress tested, right, to leave, just opt out of this experiment. They left this open for a week to receive feedback and these opt-outs, right? And they also made a webpage for all the IP addresses at each IP address of the relays that would be hitting machines in stress testing, so that if someone was curious, like, why am I seeing so much traffic from this IP address? If you go to that IP address, there's a webpage, again, explaining the experiment and what they're doing to anyone who is like curious about what's going on, right? So basically here, what I wanted to point at is try to do an experiment in such a way that limits the impact. Doesn't necessarily only have to do with coming up with new cool techniques of how to do it, right? Sometimes it's just about trying to run your experiment in such a way and informing people and getting them involved in your experiment. I mean, not very greatly, but at least keeping them aware of things so that, you can do this in a more transparent fashion, right? Okay. So now let's talk about the Tor Research Safety Board. I've been making allusions to it for some time now. So basically, what is it? So the Tor Research Safety Board is basically us trying to gather up our learnings and our experience to help the research and empirical research community, the Tor research community, right? After having had some experiences doing this sort of thing, right, we've developed and maintain a set of guidelines for researchers so that they can use them to assess the safety of their own Tor research. And when I say Tor research, I mean the empirical, on the real live Tor research. I don't mean like, some theoretical stuff. This is mostly about how to do research on the live Tor network, right? And for anyone who engages with the Tor Research Safety Board, like basically goes through the process of writing a proposal, saying this is what I want to do, we provide feedback to those researchers, right? To help them assess the safety of their planned research. Okay. And the third thing we like to do, or we have been doing, is to teach or inform program committees. This is for what I mean is the program committees at conferences about our guidelines and encouraging reviewers to consider this research safety when reviewing Tor papers, right? You may have seen in conferences, if you're a reviewer, there's now explicit boxes about, is there any ethical concerns about this research, right? And sometimes they even say, I think the PETS one definitely says that, examples of ethical, like have you been ethical is, or have been considering the ethical implications of your work is like, have you been through IRB or the Tor Research Safety Board as an example, right? So we are seeing this sort of thing and kind of seems to be happening around the time where we have been also asking these kinds of questions in the Tor Research Safety Board. So, kind of taking a step back, it seems like this is a kind of a trend in overall in research, in the computer security arena. So it's good that there is this alignment. Okay, so let me quickly just go over the guidelines real quick. That, basically these are just evolving. This is what we've found so far. It's not to say this is the perfect set of guidelines, but it's a great starting point, I think, right? So use a test Tor network whenever possible. We have, things like Shadow that will allow you to run Tor under a simulated environment or emulated environment, right? There's other things for smaller networks like Chutney. You can set up your own network inside your lab. Whatever it is that you can do, you can try to, if you can, try to do your experiments on a test Tor network, right? If you can't, for some reason, maybe there's a reason why a real live network is required. You need something in it that it has that like sometimes it's just, we need other user traffic or we need realistic load or something, right? If you can't do that, then try to only, if you're like working on an attack or something, it's safest only to attack yourself or your own traffic, right? So if you have an attack that can take down a relay or do something bad to it, set up your own relays and attack them, right? Or if you're going to collect some user traffic to show I can de-anonymize things, best to just send your own traffic in and de-anonymize that and try to limit other people and impact to other people. If you're going to be making your data available, then make sure that it's safe to make it public, right? Think about what could be the implications of making this data available, right? Try to also minimize. Try not to collect everything just in case. Like, don't go on a fishing expedition. Try to really think about what data do I need, right? Take reasonable security precautions, right? Like, this is what I mean is like access to the systems you're running. You know, sometimes people say, oh, we've anonymized the data, or hashed it using some key, and we need to keep the key around because later maybe we need to link back the pseudonym with the actual person's information, right? So make sure that can't leak, right? Limit the granularity of the data if you are releasing it, like use bins or add noise, as example I showed previously, right? Always try to show that the benefits are outweighing the risks. Right? You know, every time you do something on the Tor network, there is some level of risk, right? So just try to reason about it, to see, do the benefits actually outweigh the risks? Consider, if you can, auxiliary data. Now, I know this is very difficult to know what third-party data sets exist, but maybe you are aware of some, right? So if you're going to release data, see, hey, can it be combined with that? And will that give a better idea for the adversary to do an attack, right? And finally, consider whether a user meant for data to be private. Maybe you don't think, it's anything sensitive or important, but maybe try to put yourself in some other person's shoe, some hypothetical person perhaps, and see, did they want this information to be public? Like, for example, you might be like, hey, let's find out what all the different onion services are, right? And let's find them and let's find their onion addresses, for example. I know, and now I'll make all these onion addresses public. Right? And you'd be like, well, I mean, why shouldn't people know what the addresses are so then people can actually go to them? Maybe this onion address is private. Like, I mean, it's not meant to be on a public place, right? It's not private in that sense, but maybe no one wants you to find it, right? All right. So these are some of the guidelines that we have. Submission process and after, just to give you a sense, if you haven't already submitted ever to the Tor Research Safety Board. So there's 4 aspects of your proposed of what we want to know from you. And this is what we would ask you to write up. And basically, most of it is about making you think, right? Making you think so that you've considered it and you can write down whatever the answer you think is appropriate, right? So basically, at the very high level, what are you trying to learn? Why is this useful, right? And what is this hope for benefit of running this specific experiment? How does it fit into your whatever it is that you're trying to learn, right? After that, what is exactly your plan? Like, how are you going to go about it? This is the how, right? So what steps of your experiment will there be? What will you collect? How will you keep it safe and so on? If you've ever run, projects in maybe some like the UK or somewhere else, there's always this data management plan, right? So think of something like that. Like, how are you going to safeguard the data? What are you going to do, right? Please think about what attacks or risks might be introduced by you doing this, right? We will try our best to think about it too, but it's great if the submitter, the person, the author, has also spent time thinking about the attacks and hopefully have discovered some and then been able to say, this is how we can mitigate these attacks, right? And also then, after all that, basically kind of weigh the benefit. You're like, okay, this is what I'm planning to do. These are all the problems. Can you show us why whatever it is that we're trying to discover outweighs these risks, right? Basically, why should we still do it, right? So after you submit this, hopefully, I aim to get things kind of done in 2 weeks or 3 weeks, depends on the reviewers. But basically, you'll get up to 2 reviews, right? And there's basically 3 real outcomes. So the risks outweigh benefits. Basically, too risky and the benefits aren't that clear. Please don't do this, right? The second one is fixable problems. Basically, we see the benefits are there. We see some experimental, empirical methodology issues. Here's some suggestions you can do to fix this stuff. And then the no issues, as I had mentioned before. The other is sometimes we get submissions which are not experiment proposals. They're kind of like just not really something that we can review. So that's what the other is about. As for how the process is, it's sometimes very interactive. You know, we use hot CRP and you can have a discussion while on the submission website itself, and the reviewers get a chance to speak directly to the authors. One thing you should know, the authors and reviewers are not anonymous to each other, so everybody knows everybody else, basically. All right, so some questions. What about the bad people who don't care about being safe? That is true. That is true. Like I said before, I'm addressing the people, the researchers who want to do things in a way that would be trying to prevent harm to people that are using the Tor network, right? There's definitely bad people who are like, when I say bad, what I really mean is that people who are trying actively to discover who's talking to whom, who are doing the attacks, they're already on there, right? They're already doing it. But this is not targeted at them, okay? So even though there are people who don't care about being safe, I think it's worth for people who do care about those things to try to do things as best as they can, right? And I think as a community, that's also what we are wanting, right? Another question is, well, can't I just run my Tor relays, do my experiment without telling you? Sure. We do not police, we can't tell if you're running an experiment actually, right? Maybe there'll be something that tips us off, like when you see like a huge influx of new relays or a large amount of traffic or something like that. Maybe that will tip us off. But at that point, we're not sure if that's an attack or you running an experiment, right? So it could be that, the defenses that Tor project has in place to try to prevent someone from attacking the network may, affect the experiment that you're running. So for sure, you can do stuff without telling anyone, right? But you may not be able to, you may not get what you are hoping in terms of a pure, clean experiment. And also, at some point when you submit the paper, someone, especially nowadays, will ask like, hey, it seems like you were doing something where perhaps there's some ethical concerns. What did you do in order to, de-risk and make this more safer? Is the Tor Research Safety Board an ethics board? What about IRB? I'm taking these questions together. No, the Tor Research Safety Board is not an ethics board, right? You may in your university have an institutional review board. You should still go through that if that is what is required of you. In fact, they will find stuff that the Tor Research Safety Board is not going to actually be looking at. Things like harm to people, what is ethical research, when human beings are involved and all that stuff, right? You should still go through that if you have one of those, right? It's a good idea to do that. The Tor Research Safety Board, all it really can provide you is for us to be able to say, the set of experiments you're running seems risky or not. Here's some ways of helping you make it less risky. Or try to dissuade you if you're doing something super risky that we don't think there's any benefit to it or not perceived benefit to it, or it's not possible to do it in a less risky way. It's just too dangerous, right? So basically, we're not an ethics board, okay? That's why it's a Tor Research Safety Board, not the Tor Research Ethics Board. What about confidentiality? Now, you're coming as someone proposing something, you're coming at a very early stage in research, right? You are presenting an experiment you want to run. There's still a long way to go. You have to run the experiment, collect your data, all that stuff, right? So you may rightfully be worried that someone may not scoop you, right? One of the reviewers, right? So here, I mean, I think the only thing I can say is that we have, from set of reviewers, these are people we know, right? From the Tor community, from the pets community. A lot of them are academics. So basically the same level of confidentiality goes into reviewing papers, goes into reviewing the proposals that go into the Tor Research Safety Board. And since everybody knows everybody, in the sense that there's no anonymity, that's another further level of, who the reviewers were that were looking at your proposal. Now, you might ask, well, how will we know the right balance between benefits and risks, right? Now, of course, this is an ongoing process, right? We're trying to figure this out as well, right? We think we know, at least at this point in time, what are the kinds of risks and benefits that we could be looking at, but there might be new benefits and new risks that we haven't perceived yet or conceived of yet, right? So you're kind of helping us figure things out too by submitting these proposals, right? The committee, basically the reviewer committee that we have, it's split between Tor people and academics. We try to have a good mix so that no one side is too one-sided. We don't want it be the case where there's people who only want to protect Tor and run no experiments, and we also don't want to be the other way, where they're like, research first, forget everything, who cares? Research is more important, right? Another question might be, so do we want conference to adopt our guidelines, like specifically what we have said are good ideas? No. What we're basically hoping that will happen is conferences will adopt this thing of asking people, have you thought about the implications of your research? Have you thought about the implications of running this experiment? What have you done in order to de-risk it? It's up to the author to be like, okay, I can take the Tor guidelines or some other guidelines, whatever makes sense for your research. Finally, as I mentioned earlier, Tor is collecting lots of metrics, lots of data, right? So is Tor eating its own dog food? It has started to. And it wants to do more. Like, for example, proposal 238, for those who know what Tor proposals are, basically it's a proposal for, shall we collect this kind of data? And we'll do it in a way that's more privacy preserving. So before we didn't have hidden service statistics. Now, hidden services are quite, let's just say, more sensitive in the sense no one wants to know, one, how many exist, or at least knowing how many exist may be sensitive, right, itself. And two, how many people visit them, like how popular they are, right? So both of these things are quite risky things. So Tor was like, okay, we want to collect this kind of information, but we want to do it in a way that is safer, right? So what they did was they do binning in order to make sure that there's not, they make sure that the numbers are kind of rounded up. They also add additive noise. It's basically, you can think of it as differential private noise before making these statistics public, right? This specific proposal, it runs on hidden services, but it's opt-in. It's off by default. The code is there. If you are running a hidden service, you can turn this on, and you can help the Tor project out by collecting this data, right? But of course, there's more work needed. Okay. So I'm going to stop here, because I don't want to take up all the time. I want to give some time for people to ask questions. So, fire away.
Yeah, thank you for the very insightful talk. And how Tor community ensures the safety, minimize the risks is very encouraging. And now I'm thinking about whether we can, first of all, I think this community-specific safety board really makes sense because, for example, IRB is a very general ethics review board who may not have expertise in the domain, right? And having such a community-specific board, they have the expertise, they have the knowledge about the research, so it makes sense. Now I'm thinking about whether we should also have some community-specific review boards for example, vulnerability research, GitHub community, open source community, this kind of community-specific ethics review boards. Then I have a question for you. How can we get started with such a community-specific ethics board? For example, how can I establish review board for vulnerability research, for example. And in the morning, Speaker Eric mentioned that we may collect some negative cases, unethical cases. We can start from there. So can you share your take on how we can get started with the new community-specific ethics review board?
Right. I mean, there's obviously the know-how and, the technical tools and things of that nature. There's the other aspect of it, which I think is more the human side, the social side. Like, I'll give you the example of the Tor Research Safety Board. Like, you can see that it took a couple of years before the Tor Research Safety Board actually got underway, right? And what I find is that I think it really has to do with having some critical mass of people who basically care about having one, right? And getting them to kind of coalesce around something. For us, it was the Tor Research Safety Board. Like Roger Dingledine spoke to me many times. He was like, Tariq, you should, write this up and stuff. And, those were my postdoc days. So I was kind of like, not paying too much attention. And then Roger was like, I made it, right? It exists. Here's a webpage. Tor Research Safety Board is real now, right? And we kind of just went about it basically by saying, we made it. So, and then inviting people on to be on the committee. So we went to people who had done kind of experiments like this before, in the sense that we knew that we had people who already bought into doing things in this way, in this, this community, like what you were saying, like vulnerability research, for example, the example you're giving, or in the Tor case, people who had been using the tools, because they showed they wanted to do it not in the way that was less safe. They wanted to do things in the safer way, right? So I think community building is one aspect that is kind of I think the thing that can really keeps things going, right? I mean, I know, sometimes it's a struggle to kind of, people are like, say, yes, that's very cool. That's very exciting. We should definitely do this, right? But then it's hard to get them to actually commit to doing or putting in some time, right? So that is definitely one thing there, right? And now that was the human aspect. And the other aspect that you kind of said is like you mentioned the negative cases and things like that. I think having some set of ways of doing things, being like, that's what you can use. I can point to something specific, so that you're not just saying, ooh, this is something you should think about, be careful, but you give people some actionable steps to take, especially people coming in who are just wanting to do some research, and it feels like you're raising the bar. You're like gatekeeping, saying, oh, we won't let you pass because now you have to do some more hoop jumping, right? To give them actionable things to be able to, carry out the thing as you wish them to do in a more safer manner. I think that's also a very useful thing. I hope I answered some parts of your question.
Thank you. So I know we're running a little behind, but I want to ask a question myself, Tariq, if you don't mind. So this morning we had a speaker talk about negative examples and how negative examples in ethical research is very useful because it helps the communities understand that's the wrong thing, that's too far. And you shared an example of this in the pets community with the 2008 study by McCoy et al., where they looked at a bunch of stuff on exit relays, and that was a bad example. That was a negative example. So I'm curious how many of these sorts of negative examples have come into the Tor Research Safety Board? And if there are some, do you see a path to sharing those somehow with the community so that other people can have those examples so they know where to set their own standards when they're doing research?
Right. That's a really good question, Rob. So the Tor Research Safety Board, over the course of the years, has seen around like 40 proposals. So these were 40 proposals proposing some sort of experiment to run a real-life network. Of those, I believe around 5 or 6 of them were basically straight up, don't do this. This is too risky. There's nothing that we can say to make it less risky. Like basically straight risks do not outweigh the benefits kind of thing, right? And of course, as the researcher who proposed this, it's kind of a question of, I do ask proposals once they've come in and once we've kind of reached a verdict, is like, are you okay with me sharing this, right? And it's understandable for the researcher to be like, no, like, I don't want this to be known, right? And part of that might be because maybe they're trying to fix it. And part of it is also like, it might not shed something, like basically maybe that experiment or that line of work in a good light, right? So one way I thought that might be a way out is to kind of take the negative examples and try to make it, like, extract out the general shape of those things, right? So it's not specific to any particular project, any specific experiment that was given, right? The details are removed. But it kind of gives a sense of, okay, if you're going to do this kind of collection of data, if you're going to try to answer this kind of question, because there are certain types, right? Then, given what we know how to do safely today, these are the kinds of questions that we're saying are not going to be able to be done on the Tor network in a safe fashion, right? In fact, I've been meaning to, try to do this for all the different examples that we have, all the different proposals that went through the Tor Research Safety Board. Some of them we just made available so people can browse them on the site, but definitely the negative ones, the ones that are not shared. I think the best way to extract out some useful negative examples from it is to try to generalize what we can learn from these set of proposals and try to, kind of write about them in a non-identifiable way and say, okay, if you're trying to do these kinds of things, I think these are too risky to do. So that the next, as you say, the value of that is the next person that comes along can look at the guidelines and also the negative examples and like, oh, someone has already tried to do this and it was already considered too risky. Maybe by looking at that negative example, they can think even harder and be like, we could probably figure out how to do this in a way that the committee hasn't been able to figure out. And then you can tell us how this negative example can turn into a positive thing.